Today we're going to see a little bit in detail the transformer element. We're going to learn more details about it. So I have put the transformer element, the bond graph element in there, and I want to put the equations as well as the block diagrams next to it, and then we will see examples of this element in different energy domains. Like for example, in this case, if you go in here and we say, okay, what's the equation of this? You see, this is the module M of the transformer. Let's call it numbers 3 and 4. Okay, so in this case, you see, I would like to put this in here just to illustrate for you where things are. And this is F sub 3. So the reason I like that is because you see, if you look at if you are standing on the element, look to your if you are facing the element, look at the left. There is an effort coming in. Multiply by the modulus M is the effort at the other end. So F3 times M is F4. Now, what am I saying? It's E3 times M is E4. So that's what we need to write down. See, the input times M equals E4. So we have that E sub 3 times M is equal to E sub 4. But on this other side, you see, this is the flow into the TF, which is F sub 4 times M is also F sub 3. So F sub 3, excuse me. So this is F sub 4 times M. This is going to be equal to F sub 3. And then if you look at the block diagram of this, you would have a situation where you have E sub 3 multiplied by M is E sub 4. And then this is F, on this case F sub 4 times M is equal to E sub F sub 4 is F sub 3. Okay, if you have the other one over here, let's say this is, I'm just going to put it there. I'm going to call it M prime, but not get it confusing here. This is F sub 3, and how are the equations here? The equations here is going to be like F sub 4 times M prime is F sub 3 times M prime is F4. So let's just see, F sub 3 times M prime is F4. And then you have that the other one is that E sub 4 times M is E sub 3. Times M prime. Let's just erase this. Let me just give you some examples of this, and with that we can see the sorry, the block diagram I'm forgetting to do. See here, you know that the efforts in here E sub 3, you have M prime, and then you have, this is E sub 3, this is E sub 4, yeah, and then you have it like this, M prime, and then you have F sub 4, and you have F sub 3. This is in general. Let's just say example of a mechanical system. If you have like a lever, you know, like this, with L1 and an L sub 2, and then you can apply the force F1, and this is F sub 2. We have a rotational example, rotation, and you could have a set of gears like this, you know, where you have omega 1 and you have omega 2. R2, and this would be R1. So in the rotation, or you can have it in the hydraulic domain, you could see ram. Sorry, we'll just close this. If you have in here an example for this, like this. This hydraulic ram. So you have in here the velocity and force on this side, and you're gonna have a volume, flow rate, and a pressure on this other side. This is the example of examples on each of these. We could write the equations for each one of these. I'll just do it real quick so we don't make this too long. You know, you have that F1 times L1 is L sub 2 times F sub 2. If you write this in the form of that we just did upstairs, you could have F1 times L1 divided by L sub 2 is F2. This is exactly this form right here. See? It's like this. So if you know, this is the example in here that can actually, let's see. So that's for that. But if you happen to know this is the velocity v sub 1 and this is the velocity v sub 2, then you know that if you multiply f sub 2 times L1 or over L2, you should be getting equal to see, no, the velocity is v sub 1, like this. Same thing over here. You have that the common velocity of each one of this, that the velocity is omega 1 times r1, but the velocity is also omega 2 times r sub 2. Consequently, if you divide both equations, you could make it that you equate omega 1 t1, no, r1 r sub 2, and then you could say that omega 1 times t1 over t sub 2, no, t r over r sub 2 is equal to omega 2. That equation is like this, see? So, and then finally I will write it. If you have in here, you have a force in here, F, and this you have a mass, and your mass has a velocity in here. You know that the pressures need to be transformed from pressure to over here on P sub 1 and P sub 2. So you could say that you have that the force multiplied by the force is pressure divided by the area. Okay, so the force is equal to, no, pressure is equal force divided by the area. Okay, so that area is here like this. So the velocity, because of the volume in here, the volume B1 is related to the volume B2, or this is the, you could say that Q, so 1 is the result of the area multiplied by the velocity. This in itself is the form, is this form. See? Because you are multiplying this F times the modulus, and you're getting this. So that is the way we will figure this out, and then you have the pressure multiplied by the area is the force. So that's how you have transformers in different energy domains.